All right. Hello, hello. I am back for more Advent of Code now. We left off last time we did day 18, and now I need to do day 19, day 20, 21, and 22. Let's see if I can do them in I have about like 2 hours. They can be solving the problems for today. Let me open my code. Advent of Code. Okay. So we copy paste day 18, day 19, input main. Hello? Hello, hello, hello. Igorly. Oh, wait, hold on. I did day 18 instead of day 19. Okay. Day 18 needs to be reversed. All right, let's read what the day 19 is about. Day 19, aplenty. The elves of Gear Island are thankful for your help and send you on your way. They even have a hang glider that someone stole from the desert island. Since you're already going that direction, it would help them a lot if you would use it to get down there and return it to them. As you reach the bottom of the relentless avalanche of machine parts, you discover that they are already forming a formidable heap. Don't worry though, a group of elves is already here organizing the parts and they have a system. To start, each part is rated in each of 4 categories: extremely cool looking, musical, aerodynamical, and shiny. Then, each part is sent through a series of workflows that will ultimately accept or reject the part. Each workflow has a name that contains a list of rules. Each rule specifies a condition where to send the part if the condition is true. The first rule that matches the part being considered is applied immediately, and the parts move on to the destination described by the rule. The last rule in each workflow has no condition and always applies if reached. Consider the workflow like that. This workflow is named example and contains 4 rules. You have workflow example where considering a specific part, it would perform the following steps in order. Rule x more than 10 than 1. If the part x is more than 10, so the cool lookingness is more than 10, then send the part to the workflow named 1. Rule m less than 20. If this does not apply, then we check this and send to the workflow named 2. Okay. If a part is sent to another workflow, it immediately switches to the start of that workflow instead of the and never returns. If a part is accepted or rejected, the part immediately stops any further processing. The system works, but it's not keeping up with the torrent of weird metal shapes. The elves ask you if you can help sort a few parts and give you the list of workflows and some part ratings, your puzzle input. For example, so this is the workflows. This is the workflows. Workflows are listed first, followed by a blank line, then ratings of the parts the elves would like you to sort. All parts begin in the workflow named in. In this example, the 5 listed parts go through the following workflows. Sure, ultimately 3 parts are accepted, adding up the X, M, A, and S rating for each of the accepted parts. So capital A is accepted and capital R is rejected. It's like the special workflows, I guess. And we just add their numbers together. Okay. All right. What is this format? Is this one of the existing formats? That's not JSON, but something similar. All right, we'll parse it by hand, I guess. Anyway, okay, I get it. We do the brute force here, then we see about the part 2 what we will actually need to do here. The example is this, and then the actual input. We get it here. Save to day 19 input. No. Day 19 input. Okay. There you go. So the first we have the workflows. Workflows is a hash map from a string to a workflow, right? What is workflow? Workflow has rules, which is just a list of rules, right? And a rule is a condition, which is optional condition. What are the conditions that we can have? Or only more than or less than? Is that all? Condition, optional condition. And then we have the destination. Destination can be either accepted, rejected, or workflow of a specific name, right? Actually, I don't want to have lifetimes here, so I'm just going to clone the strings arc string. There you go. Okay. What do we have about condition? Condition. Condition is what, right? So category, and then we have operator, and then we have constant, which is going to be an integer. Let's see. Category is one of the extremely cool looking musical, aerodynamic, and shiny. Okay. Hash map, sure, import that. Then we have the operator. Operator is either less than or greater. Let's just do less or greater. All right. So now I do something like implement from string for category. From category, right? Let me do the error to be nothing here. From string is going to be okay. Match string. So category is either X, M, A, or S. Okay. Then we have the operator. I'm also going to do from string. For operator. So I'm doing the same stuff. If it's more, then it's greater. If it is less, then it's less. There you go. Condition from string for condition is going to be so we have the condition, right? So I'm just going to have the first symbol to be the category, right? Category is going to be string the first symbol. I'm going to parse that. And then we have the operator to be the second symbol, basically. We parse that. And then the constant is going to be everything else. Right? So this is that. And the rule. In order to parse the rule, I need to have the condition and destination here. Okay. Let's see. So we have it if we have a colon, right? Basically match finding the colon, right? If it is some, then it means that we have the condition. Otherwise, we don't have the condition. Condition is going to be some everything before the colon is going to be parsed into the condition, and then everything after the colon is going to be the destination. After the colon, so colon plus 1. Everything this is going to be parsed into the destination. Okay. If we don't have a colon, then we have condition to be none, and destination is just we parse the string itself. Hi. Hello, Dust Razor. So now I need to do the parsing for the destination, and that thing is pretty. Hello. CodeMonk. Hello. Is that the alt account of CodeMonkey? Okay, so I'm going to match the string. If it's A, then it means that we are accepted. If it's R, then it is rejected. Otherwise, it is us sending to the workflow of this thing. All right. Okay. So the workflow, I can parse the workflow too. Let's just keep on doing the parsing using the same implementation of from str. I'm going to ignore the errors. Okay. So first of all, we find the position of the bracket, opening bracket. We find the opening curly bracket. All right. Then we also so we basically, let's see, the name of the workflow. Name of the workflow is everything before the opening bracket. And then we take everything after the opening bracket, we strip the suffix of the closing bracket. Right? And then we do so we have the name and we have the rules, which is going to be the remaining part of the string. We split that using a comma, and then we map that into parsed list of rules, basically. This for workflow, not for the rule. This must be here, so I should unwrap. This should be collected into a vec. All right, so now in order to read the workflows, in order to read the workflows, I will do input lines, right? Take while. Take while. The garden seed challenge was fun. Part 2 would have take hours if you cheesed it. What's the garden seed challenge? Is that like one of the next days of the advent of code? The yesterdays? Or what? All right, we are going to get there. This challenge over here is mostly about the implementation, at least so far. I'm still just reading the input. Yes, it is day 21. All right. Here's a question. I know that there is an API which is take while. So right, can I take while the string is not empty so that I can see the empty line, and then, but then I want to have the remaining part of the iterator. Maybe it will work if the mutable reference to the iterator is an iterator itself. I don't remember. The iterator, is the iterator implemented? Implementers. Is the mutable reference to the iterator an iterator or not? I don't see it here. So I guess I can, okay, sure. Let's do this. Let's do this then. Workflows and the parts. I'm just going to take the input and I'm going to split it once using the two line separators, right? So then I take the lines of the workflows and I map those into parsed workflows, basically. Right? I parse the workflow, and then I say workflow name and workflow itself, and this is our thing here, right? This is the workflows. This needs to be double. All right, and then we parse the parts. Parts line. Is it lines? I think it's lines. Yeah. This is going to be just a list of parts, right? Now, what is a part? Is the remaining thing. Part is going to be the categories. Is a hash map from a category into its value, basically. So this is all the things. This is a struct. Then we implement from string for part, right? So we strip the prefix of that. We strip the suffix of that. Then we split using commas, right? Then we map that into category. Okay, so over here we have the category, so I need to split once using the equal sign, right? This is going to be the category and the value, right? So I return the category parsed and the value parsed, right? So the only thing that is left is to me to be able to have the category in a hash map. For that, I need to derive partial equality, equality, and hash. I can do copy clone. Sure. So this is me just reading the input. It took me 20 minutes. Amazing. Day 19. Okay, I have successfully read it. The example also has been read successfully. Let's actually solve the problem now. So I just need to go over my parts. I always start with the first one. What is this? In. Or is there a special workflow which is called in? All parts begin in the workflow named in. Okay. Sure. So let's go here. For part in parts. Right? We basically go and start with the with the thing. The current workflow is going to be equal to in, right? So then we loop. We loop. And we figure out if we have been accepted or not. If I have been accepted, then we add to the answer the sum of all the categories, right? Values, copied, sum, right? then we print out the answer in the end. Consider specifying the generic argument. Yeah, so I'm summing those into an integer. Okay, now we figure out if we are accepted or not. So we're going in a loop basically, and we figure out what's the next workflow is going to be. So workflow is going to be the reference to the workflows of the current workflow name, right? It always exists there. So then we just go over the rules for rule in workflow rules, right? We check if the rule actually applies, right? I mean, let me extract those into a method here, you know? Let me extract this into a method. I'm going to basically match workflows of the current workflow apply to the part, right? And this is a method which for the part returns the destination, right? Destination. So yeah, basically I'm either accepted or rejected. So if I'm accepted, then I'm breaking with the value of true. If I'm rejected, then I'm breaking with the value of false. If I have the workflow next, then I just change the workflow to be equal to next, basically, right? Next does not live long enough. Okay, sure. Yeah, sure. It's going to be arg string that I'm using here. So this is my next workflow, basically. In that case, now we just need to figure out how do we apply the workflow to a part. So we just go over the rules, right? And if rule condition let some destination is rule apply to the part, and we return the destination. In the end, we say that it's unreachable because the last rule must be something that is always applied, right? So now we generate the apply method for the rule, which is returning optional destination. So basically, if self condition is none, then we return the destination as is, right? I guess I just do self condition map or. So if the condition is none, then I'm going to basically apply the rule, right? Otherwise, if we have a condition, and to do as ref here, I think. If we have the condition, then we need to check the condition, right? Condition check for the part. So this is going to return the boolean, and then if this is true, then we return self destination cloned, basically. There you go. And now we implement the check of the condition for the part. Okay. So the actual value, part value, is going to be part value of our category that we need, right? Then we have our constant, and we need to basically check our operator that it matches the actual comparison of the part value compared to the constant, basically. Part categories, yeah. And then we have the matches on the operator. So we have the ordering, which is like the result of comparing two things, right? So like, I'm not sure. We only have less and greater. Like if we have equals, do we have less than or equals? I don't know. But actually, I'm just going to match self together with the comparison, right? And these are all the things. But I guess no matter what we have right now, if the ordering is equal, then I'm returning false. Well, actually, hold on. I just want to see if we say that it should be less, then it should only be that it should only have the less, right? If greater, then it should only be the greater. Otherwise, it's false. All right, and match expression looks like the matches macro. No, I don't like that. I don't like that lint from Clippy. Allow Clippy match like matches macro. All right. So I think this is it. This is the entire thing implemented. So for the example, the answer that I got is 19,114. Exactly. There you go. So now I just run it on the actual input. And we're done. It took me 30 minutes to like write this. Just parsing of the input, I guess. I could have made it like less. I don't know. I don't know what I would have done differently to make it faster. All the problem was just implementing the input, I think. Let's submit. This is the right answer. You're one gold star closer to destroying store operations. Let's continue to part 2. Even with your help, the sorting process still isn't fast enough. One of the elves comes up with a new plan. Rather than sort parts individually through all of these workflows, maybe we can figure out in advance which combinations of ratings will be accepted or rejected. Each of the 4 ratings, XMass, can have an integer value ranging from a minimum of 1 to a maximum of 4,000. All of the possible distinct combinations of ratings, your job is to figure out which ones will be accepted. In the above example, there are this many distinct combinations of ratings that will be accepted. Consider only the list of workflows. The list of parts ratings that else wanted you to sort is no longer relevant. So we just ignore the second part of the input basically now, and we calculate the distinct combinations of ratings that will be accepted. Okay. Okay. I think this is very similar to the other one. I'm wondering what is my input here. How many rules do we actually have here? We have 500 rules. We have 500 rules. Okay. I see. Okay, here's what we're going to do. So the graph of the workflows, so like from one workflow we can go to another workflow, right? But if we construct this as a graph, it is going to be an acyclic graph, right? Basically. I just want to say that I can like process the workflows in order, and for every workflow I just want to know all the different like segments. I guess it's 4-dimensional segments, which is like, I don't know, how do you call a multi-dimensional segment? I guess in 2D it would be a rectangle, and in 3D it would be a cuboid. What's the generic name of that? I don't know. Well, yeah, I guess the difference is because it's multi-dimensional here. And can I even do that? Can I even do that? Wait, wait, hold on. So we have 500 hyperrectangle, it seems. Yeah, I never heard anyone talk about that like a hyperrectangle though. Hypercube. Yeah. Um so Wikipedia says. Yeah, okay. Hold on. How many different values inside our rules do we have? How many rules in total do we have? Let's print out that thing. How many rules do we have in total? Let me do that. For workflow, so like workflows, values for every workflow. I'm going to take its rules, and I'm going to take its length, the number of rules basically. And I'm going to add those together. Right? Let's print out. Let's debug. Total rules. There you go. This is the amount of rules in total, basically. And it is 1582, which is a little bit too much for what I wanted, for what I have in mind here. Let's do a different thing. Let's total rules. Let's calculate total rules based on the category. Based on the category. So it's going to be basically a hash map from category to the number of rules of that category, basically. So I'm going to do a flat map. Wait, if I do a collect here, then it's not right. If I collect from an iterator, which is a tuple of category and like, I want to find the number of occurrences of a thing, basically. Is there something in the itertools that can help me with that? Rust, itertools. No, I cannot find the number of occurrences. Okay. I feel like that's something that should be in the iter tool. So let me write this by scratch, from scratch myself. Right? Let me do this. Trait, iterator, text, occurrences, count occurrences of different things. So this is for the iterator, right? Count occurrences, self. This is going to return basically hash map from self item into the count. Hey, check it out. I just made a recording of my 2D MMO. Hello. What do you think could this sell? This house? What could this house sell? I don't know. It doesn't look like a shop to me. I guess not. I'm not sure. What's your question? You mean the game? You are asking if this could sell well? This is too small amount of information. Is it good looking enough? Yeah, I think it's good looking. But I don't know. I am a gamer that prefers good gameplay to good lookingness. This game is looking like good enough for me to consider playing it. Right? It's pretty good pixel art there, I think. But I just want to know what the gameplay is because yeah, there's not much shown there. Judging only the looks is just a small part of a game. Okay, let's see. So I do result hash map new, and then I do for item in self. I just do result entry for the item or default plus equal 1, and then I return the result. Okay. Wait, hold on. How do I do a for a thing that's not implementing into iterator, but that's just an iterator? Can I not do a for over a thing that's already an iterator? I just need to make it sized. Okay, sure. Let's make it sized. Then we have I need the entry, which means that self item should be hash, right? Std ops hash, std hash hash. There you go. Iterator where item std hash hash. Wait, hold on. You cannot do that right now, right? This is unstable. This is unstable. But you can do it in a where clause. Where the item is std hash hash entry, and then is another thing. All right. Action MMO with building, survival strategy, and PvP PvE scope blown to the moon. Yeah. How long are you working on the project, and how long are you planning to work on it more? Okay, so now we flat map, and then we count the occurrences of that thing. So for every workflow rules, for every rule, I guess also flat map here actually, because rule condition is an optional. I just clone that stuff. No, not rule condition. Rule condition. For every condition, I get the category. And those are the things. You started in 2001 and then it was collecting dust until this year? Alright. Nice. Is there a difference between flat map and filter map? Yes. I guess, wait, if this is just an option, then you're right. It's no difference. It actually is no difference. Filter map is actually like more, like I can do it, filter map, into the conditions, and then I can map the conditions like that. I don't know, maybe. But yeah, when you return, I guess, an option from inside the flat map, it's same as filter map, literally. Okay, so here's what I want to do, right? I just calculate the occurrences of every category inside the rules, so that I get more data about how to solve this. So we have extremely cool looking 256. We have shiny, so basically 300, right, of every single thing. This is the number of rules for everything. So if I was to do a 4-dimensional grid, for example, and take one part from every like grid cell, right? Then we would have to do like 200 and like 300 basically to the power of 4 number of cells in this grid, right? Which probably will run for too long. This will probably run for too long. And I cannot... And I will not do that. Yeah. But at the same time... Hold on, how to actually solve it then? Alright. If I start with the in, right? I can like construct my grid separately for every like workflow based on the other workflows that point us. Maybe I don't know. Maybe there's some more about the input here. Maybe there's some more about the input here. You mean to check all the search space? It's really big? No, not all the search space, but if I basically compress my search space by only in between the things that actually are inside my input, right? Well, so when I'm checking the condition x is less than 10, for example, right? Then I check like 10 minus 1 and 10 plus 1, basically, for both less and greater, right? So that reduces the search space by a lot. But I guess not enough. All right. I was just going to check. All right. What is the next thing that I want to check? Or what else do we do? What else do we do? Hello, sorry for bothering you. I want to offer promotion to your channel. The price is lower. All right. I'm sorry, but I will have to click the button to ban you. Hmm. Okay. So do we actually do the same thing as in the other one then? So we start with a big like hypercube, right? Of all the possible search space, basically, right? And then we split it when we're doing the workflow, basically. When we encounter the rule, that's basically splitting the hyperspace into two separate parts, right? Into two separate parts. So we check them separately. I mean, it will end up being the same as a grid, no? That I'm trying to do here. What the fuck is the hyperspace? Well, we have basically our search space, right? In this problem where we consider all the different rankings of all the different categories, right? So each of the four of the characteristics are numbers from 1 to 4,000, basically, right? So we have a hypercube with a 4,000 side, and then every time we do a rule, we need to basically solve the problem separately for both like smaller parts, right? I don't know. I can just try writing that. Maybe I'm just like not seeing the correct. I just think that it's going to run for a long time, but it actually will not. Okay, let's see. If part 1, then we do this. Otherwise, we do other thing. So this is part 2. And what I need to do is... here's what I'm going to do, right? I'm going to solve... I'm going to have a function that's called solve, right? This is going to be a recursive function. This is going to have the workflows, which is a reference to a hash map, right? And then we start with a workflow, specific workflow. Specific workflow is what we start with. And the current hypercube, all right? hypercube. There you go. This will return us the basically the number that we are trying to calculate here, right? Which should fit into U64, it seems. Okay, so what is the hypercube? It's going to be for every category. For every category, we have a range, basically. We have a range, right? And the constants that we have, the I32, this is also U64, I guess. Let's call this value. I'm just going to say type value is U64. Okay, so we basically have a range on every coordinate, which is like the category, right? What's wrong here? Consider using a semicolon. No thanks. So solve for the workflows. We start with in, and the original hypercube is going to be the categories. Which is all the categories, right? So over here we have a range from 1 to 4,000. 1 to 4,000. Let's do range inclusive here. Right? So that's our original hypercube, and then we just solve this thing recursively. We are currently in this workflow, right? So I'm going to go over the rules and I'm going to split my current cube based on the rule, basically, right? So this is going to be mutable. I'm going to go for rule, and so workflow is actually self workflows is workflows like this, right? So for rule in workflow rules, I will have to do if rule condition so if there is a condition, then I'm going to split basically, right? If we have a condition, then I'm going to split. All right. I'm going to split my current hypercube based on the thing, right? Let's match condition operator. It's either less than or equal than. It's like slightly different. In that case. All right, let's see. That let's get the range of the condition category. Current range is my current hypercube. Category of the condition category, right? This is the current range. Can it move out? Because range inclusive does not implement the copy crate. Wait, really? Range inclusive is not copy? Okay, sure. Let me clone that. So I have the current range, right? And I need to split it based on the actual thing, right? So in and out are the two things. Range included. I don't know, passing and not passing. The condition is going to be matched on the condition operator, right? If we say that we need to be less than the value, then it's going to be two ranges, right? So in order to pass, we need to be less than the value. So we do current range start. Wait, in the range inclusive, this is not public. All right. There's exhausted because it's an iterator. All right, I see. So I actually might want to have my own here. My own range then. Let's have our own range. Struct range. Start. And end. So we just have the range here. Okay. Range inclusive is a bit annoying to work with. You ended up doing your own ranges too? Okay, yeah, it is. Like the regular range in STD ops, right? Has the start and end. This one has the start and end public fields, right? But the range inclusive is not. What I did was non-inclusive one, but you added one to the end. Yeah, or you could just like treat the non-inclusive one as an inclusive one, I guess. I just make my own struct. And I will copy and clone them. Okay, so if it's less, then I need to intersect these two ranges, right? So it's going to be range which starts from the current range start and ends in the should be less than, right? So it's going to be condition constant -1 basically, right? And the second range is going to be starting at the condition constant and ending at the current range end. Hello, little doctor. We're being coders today instead of being gamers. In case you are interested in gaming, though, I was playing Factorio earlier today. I'm playing it on my other Twitch account, in case you're interested. Guys, I'm doing a Factorio right now on my Kobe Boy channel. Rust. This is Rust, yes. We're doing Advent of Code. Currently day 19 is what I'm doing. Part 2. Okay, and then it's greater than the passing range will be starting at the condition constant +1 and ending in current range end, right? And then the other one is going to be from the start to the condition constant, basically. All right, so have two ranges, passing and non-passing. Either of those can actually be empty. Oh no, fast code security, you cannot stand it. Coding is gaming if you have the right attitude. Yeah, or playing Factorio can be programming if you have the right attitude, right? To okay, now we have passing and non-passing range, and basically, let's first see the passing, right? If we are passing, if passing, not empty, let's have a method on our range, which is going to be called not empty, which means the self end should be more than or equal than self start. In this case, we are not empty, basically, right? Otherwise, it's like not valid range. So if this is not empty, then we should actually go to the next part, right? So I'm going to do new hypercube. Factorio is awesome, but it can eat up your entire life with the right attitude. I'm doing the Death World marathon with 600% biters. Jesus is Lord, Heaven 7. Hi, what's up? We are doing the Advent of Code in Rust, day 19, part 2. Okay, so the new hypercube is the old hypercube. I'm going to clone that, so I need to derive the clone here. And I say that the new hypercube category for the condition category is going to be equal to the passing range, basically, right? How's it going? I'm not sure if what I'm writing right now is actually going to run fast enough. Probably not, but I'm writing it anyway. But maybe it will. It depends on the input here. Maybe there is like some specific kind of input and they are not actually trying to make something specific that's not going to pass here. But yeah, so we have the new hypercube like that. And I'm going to add to the result. Add to the result, the solving. The new workflow is going to be condition destination, which I'm going to calculate, right? So I'm going to match the well, I guess also passing and not passing are going to be the original. Passing and not passing hypercubes is what I want. Actually, hold on. So in case the condition is absent, then everything, the original hypercube is what we want. Passing and not passing is going to be, I'm going to match rule condition, and if it's some condition, then we do all of that, right? Then we do all of that. Otherwise, if we have no, then we have the original hypercube, right? And both of these can be optional for non-emptiness, maybe. I don't know. Whatever. Why is that? Why is it not going to pass? Because I'm not sure how... like... I think it is possible to construct a test against my solution here, which is going to make it run very long time, basically. But they probably didn't do it. But if you were to do like competitive programming, then it usually is the opposite, and it usually the worst case scenario is always there. Hypercube. Let me just do this. Some. And none. Let me clone that. And then over here, I have passing, not empty. Then let me do this. Range. So we have the range of the current category, right? And we want to return the new hypercube for that range in this category. So I'm going to do this. This is going to return optional too. So if range is not empty, then I do it. Otherwise, I return none. And over here, I return some new hypercube. So yeah, there you go. So now we do just a tuple of the range passing and range not passing. Okay, there you go. So now we have the two things. One hypercube, which is split, the original hypercube split if we pass the rule, and the other one is if we don't pass the rule, right? So then I'm going to basically say that if we have something that is passing, right? Then I'm going to match on the rule destination. And if it's rejected, then I'm going to ignore it. If it's accepted, then I'm going to add to the result the passing hypercube volume, right? And if it's another workflow that we need to go, then we solve the thing recursively. So we add the recursive call. Right? With the passing cube here. Okay. There you go. And then I say that no. I say some. Wait, hold on. I just realized we have in Rust the construct which is called let else, right? So I can do let something to be equal to that. Otherwise, break the loop, for example, right? But what if I was to just do that? Then I cannot do it, right? Okay. So I'm going to match on the non-passing, and if it's some not passing. Then I basically replace my existing hypercube with with the not passing, so that we continue the loop with the remaining part, basically, right? Is equal to the not passing. Otherwise, if it's none, then I break, because no need to continue the loop anymore. And now the last part is to generate the volume method. So here's what I'm going to do. It's self categories values. I'm going to map every range into range end minus range start plus 1, because that's the length of the range, because the ranges are inclusive here, right? And then I'm going to calculate the product of those things. And that's the volume of a hypercube, right? So now let's see if this is actually correct. Let's run this on the example first. And on the example, I need to do part 2. On the example, I attempted to subtract with overflow. Over here, range end minus range start. Which is weird, because the range end should be more than or equal than the range start, right? I am even checking that they are not empty here. If range is not empty, then we have the passing range here. All right, let me see this here. Start constant minus. I mean, hold on. No. I'm just checking that they are not empty. Start less than or equal than end. Yes. I guess this can be called valid. This is a valid range. How can that happen? There's a bug somewhere. If range is valid, only then I'm constructing a new hypercube, otherwise it's none. It doesn't even matter if this is incorrect. I'm literally checking that it's valid. The original one, maybe the original one is not valid. I mean, it is. Right? Well, let's debug this. Debug hypercube. Let's see what we have here. So I have the range starting from 1 to 4000. So this over here, the shiny, yes, this is the incorrect one. So how did I get here? How did I get here? This is when I did the recurse. So it can only happen here, right? Let me see if over here, if I debug the new hypercube here, am I actually constructing the invalid one? I am. I am. Wait, what? Let's debug the condition. So the condition was that musical was greater than 838. Okay, wait, hold on. So I actually constructed this before. I need the shiny. When did the shiny got wrong? Over here, shiny, right? Shiny greater than 2770. So start is this, end is this. Oh, it's passing. It should not be passing here. It's the range. Okay. So I'm inserting this range. So for, yeah, okay. This range is what we are replacing the category with. Okay. Okay, and then the answer, right? This is the answer. And let's print it out. Okay, 167400907. Okay, it looks like the correct answer. Let's see how long it actually runs. It actually runs immediately. Okay. I'm pretty sure though that they could have given me an input that would make it run for a very long time, but maybe I'm wrong. I don't know. Okay, that's the right answer. So, okay, then it's not very hard problem, but it took us more than an hour just because it requires the implementation. It was not even the yeah, like if it's splitting the cube up a bunch. Yeah, like if I guess a lot of the times you are not actually splitting the cube, but like you only go in one branch basically instead of going both branches. Right? Like a lot of the time, we only go only one of these passing and non-passing ranges are some basically. But yeah, maybe there is like a way to prove that like you cannot make a bad test, but I'm not sure. All right, anyway. So yeah, this is just 350 lines in 1.5 hours. Okay. Well, solved. Day 19. I think this, at least for this problem, I think I came up with a pretty nice code. Except for the unwraps, obviously, right? I could do, instead of the unwraps, some proper error handling, but other than that, I think the code over here is pretty nice. Let's go do day 20 now. Your solution is pretty much the same. Yeah, I thought when I saw part 2 originally that I need to do something smarter. But yeah, this is like it makes sense that your solution is the same because you need because like that's just a straightforward thing to do. You just need to implement what's there. Like there's not much different that you can do here, I think. All right, let's do day 20. All right. Pulse propagation. With your help, the elves managed to find the right parts and fix all of the machines. Now they just need to send the command to boot up the machines and get the sand flowing again. The machines are far apart and wired together with long cables. The cables don't connect to the machines directly, but rather communication modules attached to the machines that perform manual and various initialization tasks and also act as communication relays. Modules communicate using pulses. Each pulse is either a high pulse or a low pulse. When a module sends a pulse, it sends that type of pulse to each module in its list of destination modules. There are several different types of modules. Flip-flop module, either on or off. They're initially off. If a flip-flop module receives a high pulse, it is ignored and nothing happens. However, if a flip-flop receives a low pulse, it flips between on and off. If it was off, it turns on and sends a high pulse. If it goes on, it sends It turns off and sends a low pulse. You really dislike this one? Let's see. Conjunction modules. Conjunction. Remember the type of the most recent pulse received from each of their connected input modules. They initially default to remembering a low pulse for each input. When a pulse is received, the conjunction module first updates its memory for that input. Then, if it remembers high pulse, for all inputs, it sends a low pulse. Otherwise, sends a high pulse. So this is basically the AND operator. So it makes sense to use that. This looks like what we are. This one is weird. It turns every even low pulse into a high pulse. And the high pulses are completely ignored. There is a single broadcast module named Broadcaster. When it receives a pulse, it sends the same pulse to all the destination modules. Here at Desert Machine headquarters, there is a module with a single button on it called Apply, the button module. When you push the button, a single low pulse is sent directly to the Broadcaster module. After pushing the button, you must wait until all pulses have been delivered and fully handled before pushing it again. Never push the button if modules are still processing pulses. Pulses are always processed in the order they are sent. So if a pulse is sent to modules A, B, and C, then the module A processes its pulse and sends more pulses. The pulses sent to module B and C so if a pulse is sent to module A, B, and C, and the module A processed its pulse and sends more pulses, pulse sent to module B and C would have to be handled first. Okay. Sure. So we just do the BFS here of the pulses or something, right? The module configuration of your puzzle input lists each module. The name of the module is preceded by a symbol after defining its type. If any, the name is then followed by an arrow. The name is then followed by an arrow. Module configuration lists each module. The name of the module is preceded by a symbol. I define its type. So what's the name of this module of the broadcaster? The broadcaster has 3 destination modules named A, B, and C. Each of them is a flip-flop module. There is a single broadcast module, I see. A single broadcast. By pushing the button once, the following pulses are sent. Button low into the broadcaster. After this sequence, the flip-flop modules all end up off, so pushing the button again repeats the same sequence. This module configuration includes the broadcaster, 2 flip-flops. Sure, here's what happens. What do we need to do? This completes this cycle. We need to do this cycle. To get the cables warmed up, the elves have pushed the button 1000 times. How many pulses got sent as a result? So I just need to like do 1000 button pushes, right? And I guess for the part 2, we'll need to figure out how much until it loops. In the first example, the same thing happens every time the button is pushed. 8 low pulses and 4 high pulses are sent. How many pulses got sent to the result? Is loading the pulses sent by the button itself. Yeah. Consult your module configuration. Determine the number of low pulses and high pulses that would be sent after pushing the button 1000 times, waiting for all pulses. Okay, I think it really depends on how many flip-flops we have in the input here. A flip-flop is a percent, and I see a lot of them. I see a lot of them. Okay, well, let's do the straightforward solution first, right? Just like what they wanted us to do, push the button 1000 times, just do it and then see what the part 2. Maybe part 2 is not what I'm guessing. Maybe it's not the number of pushes until there is maybe I'm guessing the second part incorrectly, but I think I'm guessing it exactly correct. Now let's get the example. Where is the example? This is the example. Oh, this is a more interesting example. Let's just do a more interesting example, because I can only do one anyway. This is not text. This is plain text. A 20 input. Okay, well, let's start with parsing the input again. So we have a list of modules, right? So I have a module which has a name, right? And we have let's just have modules. It's going to be a hash map from name to the module. So a module is what? Just its type and list of outputs, right? Type, module type, and outputs is a list of strings. Module type is a flip-flop. It is what did they call it? Conjunction. And the broadcast. Okay. Just simple as that. Let's parse the input. So it's going to be input lines. I collect those. So name, I am going to split once with an arrow. Let type name and outputs is line split once using the arrow, and then there's only one broadcaster, right? So match type name no, if type name is equal to broadcaster, Then so this is the type and name is going to be, in this case it's going to be module type broadcast and this string. Otherwise, if we have a name by stripping, should be unwrapped here. If we strip the prefix of a percent sign, then it's module type flip-flop with this name. Otherwise, we strip prefix of the conjunction. And we have that. Otherwise, it's unreachable. Okay, so we have the name. And we have the module where we have this type, and the outputs is going to be outputs split using the comma, and convert those into owned strings and collect into a vec. All right, so this is the input parsed, right? The input has been parsed. Now we just do 1000 times, and we so we need to in addition, for our module, right, we need to know what is, oh wait, hold on, how does the conjunction work again? How does the conjunction work again? Conjunction, remember the most recent. When impulses receive, the module updates its memory for that input. Then if all of them are high, then we send low. Otherwise, we say high. All right. So flip-flop module is going to store a boolean inside, right? If it's on or off, and the conjunction is basically going to have the memory, right? For every input. It remembers the initial default to remember a low pulse for each input. Let's have the pulse. Low or high. I don't want this to be a boolean. Conjunction. So conjunction is basically going to store for every input name its currently remembered pulse, basically. And flip-flop is either on or off. So for this one, I can do a boolean, right? So for the conjunction, I'm going to do a default hash map. And for flip-flop, I'm going to do, originally it's turned off, right? Initially off. Okay. Now I just need the conjunctions to be initialized properly. So for module For the hardest part here is because I want to iterate over this and then mutate the other part, and that doesn't work well in Rust. So I can do for like name. So this is the name of the module and its outputs basically, right? In modules, iterate map name and outputs, name and module. I take module outputs, I clone that, and I also clone the name. And then I collect that into a vec, because I don't want to be borrowing from this inside this loop. So I say for output and outputs, modules get mute for the output type. I'm going to match on that, and if it is a conjunction of inputs, then into this inputs I insert my name with the low pulse being remembered. Like that. Consider cloning. If the performance cost is acceptable, cannot borrow inputs as mutable. This should be ref mute basically. Or I could do a at mute here, which is the same stuff. And then name should be cloned. I mean, name is already cloned though, but it should be cloned again, yes. And this is the E flat. Replaced with E flat, okay. So there you go. Now, now if I have the output that goes into the conjunction, then that conjunction should initialize its input, basically. Okay, and then we press the button 1000 times, right? 1000 times. 1000 times. I do that. I send the low pulse, right? So like the pulses that are going to go basically is going to be vec it's a queue. It's a queue which is going to be initialized with so it's going to be where is the pulse going and what is the pulse, right? So we are going towards the broadcaster, and the pulse is there's probably I'm probably going to clone the strings here. How about we use the arc string again? I like my arc strings. Do do do. I like my arc strings. This is vec of tuples of the string and the pulse, basically. Okay, so we send the low pulse to the button, right? Single low pulse is sent directly to the broadcaster module, yes. What's the reason there is one broadcaster module? What's wrong with having multiple broadcast modules? Hello, just lurking? Hello, hello, hello. Enjoy your lurk here. I'm solving Advent of Code, in case you couldn't tell. Currently day 20, part 1. I hope your day is going well too. Mr. Rook rules. Low pulse sent to the broadcaster from the button, right? So then we do basically while we have a pulse for the name, right? Pulses I pop from the front here of the queue. So I calculate the number of lows, right? And I calculate the number of highs. I'm going to match here on the pulse. If it's low, then lows plus equal 1. If it's high, then highs plus equal 1, right? Token notes about the arcster. That definitely would help count the bottle checker. Or you could clone the strings, right? That's one of the things. Or you can make the lifetimes over here, which is also an option. I think I did the lifetimes in some places, or in some places I copied. Arc string is just faster to clone because you don't clone the data itself, only the pointer. So this is just the pointer to the string on the heap. The regular pointer requires a lifetime, but this is reference counts, so it's like a garbage collected string. It's pretty simple to understand, I think. So in case you are doing a lot of cloning on your strings, it might help with the performance. But usually I just do the string anyway, because usually I don't care. And I'm pretty sure we don't really need to care in this problem either. All right. So yeah, we have the pulse, right? And then we actually process this pulse. When it say that it sends the low pulse, wait, hold on. So hold on. Every single conjunction, every single every single flip flop is only connected to one output. Is that right? Is that right? Let me check the input. No, it's not right. Hold on. This is a flip-flop that is connected to two outputs. So does this count as two pulses or as one pulse? If a pulse is sent to modules A, B, and C, which means that this is a single pulse going to three modules, right? I would need to like read through over here. It's two pulses and you have to process them in order. Are you sure? Because it says over I mean, okay. I mean, probably somewhere in this example it actually says it. But I guess in the more interesting example, right? Where is a more interesting example? Yeah, over here, this one. The percent %A. Even ifcon. The multi-input conjunction module con watches the two flip-flop modules, and if they're both onside and low and pulse. That's well. Here's what happens. Yeah. Okay. So this is two separate pulses. Like just judging by the previous sentence. I was confused, I guess. The pulse is sent to modules A, B, and C. This means that this is not a single pulse then. If it's sent to multiple modules, it's multiple pulses. This should be a like plural word here, right? Okay, so then I'm actually like counting it like I should. All right. So I'm going to take the module at modules get mute for the name, right? So this is the module that I have. I'm going to match on the module type, and let's start with the broadcast. The broadcast just repeats sends the same pulse to all the destination, right? So what we do is we do for output in module outputs. We do pulses push into the back of the queue the output name cloned and the same pulse that we received. This is, let's just call this the queue. Okay, then if we have the conjunction, this is current state. If we have the conjunction, then we replace state insert where we came from. Oh, we need to know where we came from, right? So this is going to be two strings. So we are coming from the button. We are coming from the button. So we when we do the conjunction for the state, we insert for the from the pulse, right? And if all the pulses that we remember are high, then we send the low, if I remember. If all high, then we send the low. Otherwise, we send the high. Okay. So so the pulse that we're going to send is I'm going to match state values all pulse if all are high, then it is low, otherwise it's high, right? That's what they told me. Okay, so then I just send this pulse to all the outputs. I guess I can do something like send, and over here we return something. Over here we return some original pulse. And so like this calculates what type of output do I want to send to all the outputs. And then if I actually want to send the output, then I actually send it to all the outputs. So I send where this pulse is coming from, so the from is the current name. There you go. State is immutable. There you go. Now it's mutable. And then we have the flip-flop state. So flip-flop state ignores the high outputs, right? So if pulse, let's mesh on the pulse here. If it was a high pulse, then we just ignore it, right? If it was a low pulse, then we flip the flop, right? And if it was off, it turns on and sends a high. Turns on and high. Turns off, sends low. Okay, so basically I match on state again, and if it's true, then it's high pulse, otherwise it's a low pulse. Okay. I could just use the booleans to represent the pulses, but I think this is easier for me to understand. Okay, and the output, the answer. So we do this 1000 times, right? We calculate the number of low and high in the end, and answer is going to be multiplication of lows and highs, right? So for the example, we are not compiled because this should be a macro. And this is not to own, this is into. Because I'm not constructing a string, but an arg string. Okay, and then we have an unwrap. Because apparently the output is not existing. Wait, what? Hold on. Oh, there's an actual output. Hold on. What's the output? What does this mean? Did I not read about it? Output. Untyped module named output for testing purposes. Okay, so there are things like that, apparently. So maybe we will... Oh, we will probably use the output then and not calculate the number. Yeah, we will use the output in the part 2 then. I think. Let's see. So this should be just do this then, right? I should probably not unwrap in the other place over here. When I'm sending something to the output, basically, I say let some module here to be equal to this. Otherwise, I continue because this means that this is the output. It doesn't even exist. Is it weird to dip chicken nugget into Nutella? I don't know. I never did that. Doesn't mean that it's weird though. I guess. Okay, the answer is 8 million. That's probably the wrong answer. Let me debug the lows and highs. So I have the 4000 lows and 2000 highs. I'm using what example? I'm using the second example. Hold on, let me debug what's happening here. We're doing the example, right? Yes, we are. Let's debug here. Print out. So from into name. False. Right? Okay. Let's see. This is a lot that's happening here. Let's just do it once, maybe. Let's just do it once. Press the button on the example, right? So here's what's happening. We are doing button. Let's do it the same as they are doing this. They're doing dash false. Okay. So button low into broadcaster. Wait, what? Broadcaster into HD, XT, KJ, ZT. What example am I looking at? This one. The more, yeah. Here's what happens if you push the button once. Broadcaster is only connected. Wait, hold on. What is the example that I'm looking at? What is XT? Okay, I'm parsing the input incorrectly, I think. Where is the XT even coming from? Let's print out the modules. Debug. Yeah, something is weird going on here. We have the brr module. We split the line like this. This needs to have a space in between, but I don't think that matters. Hold on. What? Well, I do have the broadcaster. Broadcaster is connected to HD, XT, KJ, and ZT. What the fuck? What am I getting here in the beginning? SR. This is the first line? Is it the first line? I'm getting this input. I see. All right. Oh, wait, hold on. Am I... Yeah, I need to do example here. There you go. Let's do example. I was running for the actual input. Okay. So here's what happened. 4. Hold on. Maybe it just all works here, and I just need to do it 1000 times. I was just running it, not on the example. All right. The answer is 116.87500. All right. There you go. Now we just run it on the actual input. And we have that answer. This is the right answer. All right. Let's see what the second part is about. The final machine responsible for moving the sand down the island has a module attached named RX. The machine turns on when a single low pulse is sent to RX. Reset all modules to their default states, waiting for all pulses to be fully handled. After each button press, what is the fewest number of button presses required to deliver a single low pulse to the module named RX? Okay. So is this very big number? Can I not just do this? Let's see. Let's see. Let's see. So I'm just going to loop here. Wait, hold on. This is me doing the button, right? This is me doing the button. Let's say you just need a loop. I just want to like save the part 1 basically. Press button. There's going to be a function like this. All right, which is going to let's make it a function actually. Press button. I'll need the modules here, and I will need the function which handles the pulses, right? I'm just going to handle these from I don't know, where and what is the pulse, for example. Let's do this. So this is the handling for the part 1. Yeah. This needs to be a mutable reference, sure. Okay, so here we go. If part 1, then we do 1000 times. We press the button. We don't care where. We care about the pulse though. And then we match the pulse. And we increase the lows or highs basically. This needs to be FN mute. And we also need the modules themselves. Here. All right, so this is the part 1, and then part 2 would be just a loop. And then I press a button for the modules, and if we get a pulse, wait, hold on. Single low pulse to the module named RX. Okay. Module and pulse. So basically I say received is false. Over here I say that if module is RX and pulse is low, then we have received the thing. And if we received Then we break. So I guess we do something like while not received. We do this, and then we do answer plus equal 1. Right? This needs to be mutable. And then we print out the answer. Okay. Let's see. Example part 2. Even example part 2 is very slow. Hold on. Oh, because there's no Rx here. Hold on. There's no example that I can test it on. There's no Rx in the example. Alright, let's just run it on the part 2. Alright, let's wait for it. Let's wait for it. No example for part 2? Okay. Release maybe? Yeah, sure, let's do release. I mean, or we need to write a better algorithm, which we probably need. I was just like trying to see if it works. So I need to... yeah, it doesn't matter. So like we need to come up with a better solution here, right? I think like maybe this depends on the graph that we have here. I see that we don't have a lot of nodes, right? Do I need to understand what it all meant? All the different like operators here. We only have one broadcaster. Does that like mean something? Where is the RX? RX goes from HP. HP goes from SN and SR. Those are both conjunctions. And then HP is also a conjunction. Alright, let's think about it then. What do we need to do here? If not just modeling the thing. Do we have like loops here? Do we have loops? I want to know if I have loops here or not. Let's do this, right? Check for loops. Modules. We start with broadcaster, right? And visited is the thing that I need to know about. Let's see. Visited is going to be hash map from a string like this. Into what? To visited. So something like this. I'm just writing the depth first search and seeing if we have the loops here. returns boolean. Okay. So I take visited at the current thing, and I'm going to match. If it's well, I guess not visited is non here anyway. So yeah, if it's none, then I'm going to actually visit it. If it was some visited and I'm currently processing it, this means that I'm inside the loop. So I'm going to return true. And if it was already visited, then I just return false, because this is, I can visit the same thing twice because it's just like a cyclic graph, right? And if it's none, then I need to start actually visiting it. So visited, insert for the current. I guess this is just an arg string here already. Insert into the current visited. So we start processing it. In the end, we are going to say that we have done processing it, and we return false, right? And in between, what we're going to do is we are going to go for all the outputs. If this module even exists. Modules get current. Then for output in module outputs, we check for the loops here for the output. And if this detected a loop, then we also return true because we have detected the loop. And that's it. That's it. That's basically the depth first search. And I want to see if we have a loop here or not. Has loops is true. Okay. That's not good, I think. Because if it did not have loop, then it would have been nicer. Yeah, the example does not have a loop though. And this thing has a loop. Alright. I can return the loop itself, just so that I check that I found it properly. Let's see. Let's see. Um, this. If so, yeah, basically in case it's so false means that there is no loop. False means that there is no loop. And then if we visited something that was being processed, in this case, I'm going to return some. So I have a tuple here. The first one is what do I need to like roll back to like actually construct the loop, right? So I'm rolling back to the current one, and the loop is going to be an empty vec. Basically, we start with an empty vec, and then if let some roll back and the loop is like being constructed here, right? So I'm going to the loop, I'm going to push the current, and I'm going to return. This should be, and at some point we should stop basically. So this also is optional. So if let some roll back is rolled back, then we push, right? But if rollback is equal to current, then the rollback we reset it to be none now, and then we return some rollback and the loop. This should be cloned. This should be cloned. There you go. So now we have the loops, right? Let's see. So the loop is, wait, hold on. How many loops do we have though? Maybe we need to like see the input here. The loop is just 3 things that I have found so far. Do we have any other loops? Let's see. So we go from JH, or in the other way, let's see, JH, SB, JH, XR. So from JH we go to XR, and from XR we go to SB, and from SB we go to JH. So this is the loop. Wait, GraphViz input is almost the format already. I never used GraphViz. What is it? Is it online? GraphViz is just a thing. Let's try running this. It cannot be ran though. Is this a library? What is it? GraphViz online. So we just copy paste this and we, what is start? Is start a keyword? Subgraph cluster 1. Dgraph. What is a dgraph? Start end. Can you just make this? Syntax error. So then we just hold on. We just remove those symbols, right? There you go. So what do we have here? What do we have here? Where's my broadcaster? Can I make this be not on the half of the screen, but on the full screen? Download. Day 20. Yeah, sure. Let's just have it over here. Let's just have it over here. Let's just have it over here. How do I? Open browser. Default browser failed. Browser. Opening other browser, Firefox. Why does this thing that my browser is Chrome instead? Alright, anyway. Oh, wait, hold on. But in my GraphViz Online, I could interact with this. Ah, shit, this is so annoying. Like, why is half of my screen used here? Anyway. Anyway, let's see. Where's my broadcaster? I don't even see the broadcaster. Where's my roadcaster? Why don't I don't even see it here? Where's my roadcaster? At the top? Oh, there you go. Okay, let's see. Let's see. RX. This is the thing, the only RX that we have. Okay. All right. So it looks like we have one big cluster to the right. It all comes from HP. Maybe the loop. Wait, hold on. What is the loop that I found? JHSB XR. XR. Yeah, but this loop actually does affect the RX. XR ASB JH. 4 clusters with internal loops. All right. So the annoyance of this problem is that we need to like do something about the specific graph that we are given, or exactly that. It's so annoying. There has been another problem like that. You remember the where we one of the first days where we needed to get the lowest common multiplier something. There was also some loops there that were pretty specific. It was easier though. Maybe we can do it without the specifics, but I don't know. Now I need to know what things we actually have. So this loop is like that, all right. These are all what, flip-flops? Can I do anything about this so that I can solve it in a generic case? Let me think about that first. Can I do something like put those in quotes? If I put those in quotes, will I see also if what's the type there? This graph is so great. I guess I need to make these to all be... Oh, I see. Yeah, because yeah, the connections are lost. Yeah, you're right. You are right. I can add color red in the end. That's easier to see. Okay. Color is red. And then I just delete the first thing again. Do I even need the dgraph? I guess I do need a dgraph. This is means directional graph, right? Right. So these are the conjunctions. XR is a conjunction. GK is a conjunction. This is a conjunction. Okay. And then can I make the node colored instead? That would be easier, I think. Oh, you can do HP. Label is HP. All right. Let's do something. Yeah. So instead of doing color red, I'm just going to take all of the ends. I'm going to do this. And in the end, I'm going to say this label is at that, right? Okay. Cancel, cancel. So annoying. All right. Yeah. Maybe we just need to, I don't know. Do we need to run a visualizer for this thing? I'm running out of time though. I needed to like stop. I need to stop soon. Unless I see the solution right now, I might like do it tomorrow instead with day 21. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So like these separate loops are like separately small so that I can do a mask basically, right? Is what I understand right now. Every single loop here 5, 6, 7, 8, 9, 10, 11. I have like less than 15 flip-flops. And those flip-flops are basically all that matters. Their state is exactly the state of the input. Right? Because if the flip-flop was off, then it means that we sent the low signal and they are originally off. So the state of the flip-flop is the state of the input over here. Exactly. Want a hint? Nah, I don't want a hint. I just I need to stop the stream is the thing. The only problem. So yeah, I can basically start going in a loop here much faster than actually emulating, because I can um Let's see. How many of the conjunctions do we actually have? This conjunction is going into Sn. And this is the last conjunction. So we need all of the input conjunctions to be high, which is this loop going into, I think, before with just one input, right? Hold on. This is a conjunction, and all of the inputs of this conjunction is also conjunctions, right? I want all of them to be high at the same time, but unless all of the, so like in order for this conjunction to be high, I want to receive a low signal here, right? So all of this needs to be high. In order for all those to be high, this must be low. So all of these must become true, basically. And all of these must become true. And all of these must become true. And all of these must become true at the same time, basically. Right? So we have 4 loops. And they all, basically for every single loop, I calculate what is the period for all of the inputs to become high again. Hold on, maybe I can do it recursively from the end. So I want the receive to calculate to get the low, right? Um yeah, I almost like see it. I just don't want to do it manually. Is the thing. Split out the loops themselves. Okay, I think I'm going to do it next time. I'll think about it. It's I just don't have the time to implement it anyway because I need to stop the stream, unfortunately. I should have stopped it before I implemented the part 1, I guess, because I just didn't see that the time is there. All right. I promise you I don't cheat off stream by by looking up the solution. All right. Now this is one of the early advance of codes here. No push-ups? Nah, no push-ups. I'm sorry, Big Orly. I'm sorry, Davey. No push-ups. All right. Here's some of the early advent of code being done in JavaScript inside the browser. Amazing. All right. I guess I finish tomorrow. Bye.